All right. I think we'll go ahead and get started. Looks like we have a large group signing in. I appreciate everybody joining today. And again, please mute your mics so that we don't have any background noise during the presentation. And then if you could save your questions to the very end, that would be greatly appreciated. So before I get started, the first thing that I'd like to cover would be that we are very grateful for having you all here. We appreciate you all joining us today. And of course, during these difficult times, we know that many of you are working from home, and so we just want you to know that our hopes and prayers go out to everybody. And that we hope that you'll take the necessary precautions to protect yourselves, your families, your friends and neighbors. And of course, we look forward to the day when we can put all these times behind us. But to get started, I'd like to present quite a bit of information. It's a number of slides that we're going to cover, so we'll try to get through this as quickly as possible and try to get it all done in the allotted time that we have. So getting started, first thing we'll show you is I too am sequestered in my office. I'm cozied into my room here, but I do have a lot of equipment here with me and we also wanted to talk to you a little about the people that may not be fully aware of what a electronic load it does and how it operates. This is a basic schematic of a type of electronic load. And electronic loads, this is not our schematic of our unit. This is just kind of a basic overview. But it's advanced over the years, and Chroma has been right on top of that with their advancements in using digital signal processors for controlling it, embedding software, running at high-speed DSPs, and also by adding some advanced features. And these advanced features were developed based on the needs of many of our customers. So Chroma's done an excellent job in listening to their customers' feedback and making an effort to make it easier for their customers to test the various devices. The industries that we cover are vast. Just about any device out there that has a DC output sourcing capability is going to be something that we can most likely test with our electronic loads. We cover a wide variety of devices used in the electric vehicle and automotive industry, industrial conversion, industrial power conversion, everything from batteries to converters to solar arrays, and the list goes on and on. We also cover a wide variety of medical devices and portable devices, anything that might be a converter of a DC to DC type power converter, AC to DC power supply, batteries, battery chargers, and battery or DC type controllers, which we'll go into more detail. So the E-loads applications, like we mentioned, cover things such as AC to DC power supplies. An electronic load on the output of an AC to DC power supply will give you the ability to test the outputs range of things such as load regulation, cross regulation, even line regulation, ripple and noise is done under a load, output impedance, transient response, efficiency, overcurrent protection. The list goes on, and we're going to go into some of those in more detail. We also do a lot of battery charger testing with our loads. We also can do discharge testing of batteries, fuel cells, modules, packs, and cells. We also do things such as DC drivers, such as a DC thermal controller that would drive a load like a heating element. And because it's not practical for customers that manufacture these devices to have a variety of their devices that they drive from their source, the electronic load is great for giving you that versatility and wide range for testing all of these different products. The advanced features that Chrome has come up with over the few years and has implemented in the loads that I'm going to be discussing give you extended modes of operation. Normal operation for a load can be constant current, constant resistance, constant voltage, and constant power. And Chrome has added and extended that to include something called constant impedance, which we'll get into in more detail. Dynamic loading is something that's used a lot, the ability to pulse the load on your device under test. We've included dynamic sweep and Sinewave Dynamic to expand the capability of doing dynamic testing on your units. Programmable sequences, we'll get into that. They're basically individual sequences that can have different amplitudes, slew rates, modes of operation, and small to large timing for each. And you can do multitudes of these all the way up as many as 250. Some of our units only go up to 100 sequences. Our new products go up as high as 250 sequences. User-defined waveform, overcurrent and overpower testing, dual and multi-modes, which we'll get into, maximum power point testing for solar panels, and then of course we offer the full range of remote interfaces, USB, GPIB, Ethernet. Some of our devices are also LXI. We also have an analog input to our units that are used for a lot of different various types of controls of the output using something as a function generator, an arbitrary waveform generator. And these can be used for hardware in a loop and power hardware in a loop systems as well. Digitizing measurements capture. This is a great tool that's been added to our software, which is a general user interface for a lot of our products. Paralleling, our loads can be paralleled for much higher power requirements as needed. And then the most accurate measurement and resolution of just about any E-load on the market, which we are well known for. So the product line that we cover a wide range, and this is not all the products, but this is some of the products that we use as far as electronic loads and that we offer. So we have AC loads like our 63800 family of products that go all the way up to 4,500 watts. We also have regenerative DC loads like our 17020 that are used a lot for the battery industry to give you both a very efficient load and less dissipation of heat in the environment where it's being used, and also to give you a variety of different programmable advanced features that we'll get into a little later. High power DC loads, modular DC loads, and then our new line of small benchtop loads. We'll get into those as well. So our 63,000 E-load, this is our small benchtop load. It's a great device. I use it extensively in my demo lab. We have this unit in two different models, a 250 watt and a 350 watt. They can have voltages applied up to 150 volts, currents up to 60 amps. They also have the constant current, constant resistance, constant voltage, constant power. We're adding to it constant impedance, user-defined waveforms. They also have the programmable sequences, the overcurrent, overpower test built into the unit, and dynamic loading, and then it also has the test for battery discharge. Standard interfaces, USB, Ethernet, GPIB are optional. Physically, it's a very small, compact unit, 2U high, 8.5 units wide, 13.9 units deep. Weighs only about 13 pounds, great for a benchtop test. The 63600 is our modular unit, rack mounted, and can also be used as a desktop unit. This one has the ability to be paralleled and up to 5 different types of modules, ranging from 80 volt, 20 amp dual module, a dual load in a single module, all the way up to our 600 volt, 15 amp, and our 150 volt, 400 watt, 60 amp units. Again, these have the normal modes of operation: constant current, constant resistance, constant voltage, constant power. They have the added impedance, constant impedance mode, which we'll go into in more detail. Programmable sequences, dynamic, OCP, OPP, which is overcurrent, just like the other ones. User-defined waveform, digitizing measurement, and battery discharge testing. The interfaces include USB as standard, optional Ethernet, and GPIB. And then the big brother to these, this is our 63200 high power, high density load. It's known for its amazing density, for the packages, package size based on the power rating of these units. They go from 2 kilowatts up to 24 kilowatts. They have 3 different voltage versions, 150, 600, 1200 volts. And these units can go all the way up to as high as 2000 amps. And then with paralleling, we can get all the way up to 240 kilowatts. Has all the basic features that we had talked about before. It has all the advanced features and a few additional features that some of the smaller units don't have that we'll get into in more detail. So this is the 36 different models we offer within the 63200A family, starting with a 2 kilowatt, 150 volt, 200 amp, all the way up to a 24 kilowatt, 1200 volt, 960 amp, and 150 volt version, we go all the way to 2000 amps. So, and again, these can be paralleled all the way up to 240 kilowatts. So the advanced features we're going to cover, like we mentioned, our measurement accuracy is a big plus on our units. We'll go into that in a little more detail. Static testing and various static modes of operation, and then of course our dynamic sweep, and Sinewave Dynamic. So the other tests that the features that we offer, such as programmable sequences, user-defined waveforms, digitizing measurements, battery discharge, and overcurrent, overpower protection, and of course maximum power point tracking. So starting with our measurement accuracy. Measurement accuracy on our devices is the top of the list of when you compare us to many of the other models and manufacturers out there. Our 63200A has a voltage accuracy of 0.015% of the reading plus 0.015% of full scale. We also offer 3 ranges. So when we talk about full scale, each full scale is referred to the range that you are in. So in the voltage ranges, we offer 11, 53, and 100% range approximately. And in the current ranges, we offer 3 ranges, 10%, 50%, and 100% of the rated maximum current. So the current has an accuracy of 0.04% of the reading plus 0.04% of full scale. And again, full scale refers to the range that you're in. So because a lot of our competitors only use 2 ranges, 50%, 100%, when you're operating down in the low end, your accuracies are very poor. So with the Chroma devices, we cover a wider range with 3 different ranges. We cover a much smaller range to get you down to using the loads even at the smaller currents with even the higher power loads. The 63200A has voltage parameters, settings with resolution down to 1 millivolt, current resolution down to 1 milliamp. And it also has the measurement capability all the way down to 100 microvolts and 100 microamps. So by giving you the wide range, the accuracy, it gives you an incredible measurement capability for this particular product. So the static standard modes of operation include constant current. Constant current basically is just a regulated fixed current value, and even if the voltage were to change, it would maintain and regulate that fixed current. Constant resistance, the parameter would be set in ohms, and with that you'd be emulating the actual resistor. As the voltage changes, the current would raise proportionally. And in constant voltage mode, this is something that's typically used for a device that has a constant current output. So a device that might have a constant current output would be a battery charger or an LED driver, something of that nature. You can actually set a voltage level and the load will adjust the current to maintain that voltage level. And then constant power, it looks at the voltage, changes the current accordingly to maintain a fixed set power level. So these types of applications are used for anything for DC to DC power supplies, battery discharge, battery chargers, and many of other types of devices that we'll go into in a little more detail. Constant resistance, again, it's used many times for a start test for a telecom power supply. They may have a very sharp current limit point, and they may have a fallback current limit, sometimes starting them to a constant current load would cause it to trip that. So many people will use constant resistance initially on turn on of these types of devices. Also used for things like even an automotive temperature controller, very resistance over time. Constant voltage, again, this is something used, LED drivers, battery chargers. It can also be used to actually pull the voltage down on a particular power supply to test an under voltage setting. It's definitely used for constant current source testing. Any device that regulates and outputs a current, we would not be able to test it with a constant current, because basically the load would be trying to emulate what the source is trying to do. So by doing constant voltage, we set a voltage level, we'll set the impedance of the load to bring that device down to that level. Constant power we already discussed, again, battery testing and various other types of DC output devices, everything from DC to DC converters to actual AC/DC power supplies, batteries, and fuel cells. Constant impedance is something that's unique to our offering of our loads. This is a patented product test that mode of operation that Chroma has implemented. And it's a great tool for testing a power supply or a DC to DC converter that may be driving a load that has a high input capacitance. So normally doing constant current, constant resistance type test, you wouldn't be able to truly simulate and replicate what the current would look like if your unit turned on quickly into a capacitor. And it wouldn't be able to replicate the spike in current or the instantaneous current. So many of our customers, like this spec that you see here, actually specify what their maximum capacitive load that they can drive would be, and we can test to these values. We can use the exact capacitor value. And to show you that, we actually have a built-in algorithm to our digital signal processor, and we have a range of settings from 30 microfarad all the way up to 50,000 microfarads in 1 microfarad increments. So when we apply our load to your device, it looks and emulates an actual capacitor based on the transient or the turn on voltage and the rate of rise of your voltage applied. One way to show this a little better is a typical telecom type power supply loading its actual device, which has a capacitive input. You can see the above scope screenshot. You can see the high peak current initially during turn on, and then you can see how it varies over time. And you'll notice that our load, when we use it, set it at the same exact value for the capacitor, it will replicate that waveform almost perfectly. There's a small couple of instances where it's not exactly the same, but it's amazing how closely it'll replicate that load. So it's a great tool for testing that when you're using a DC to DC converter or an AC/DC power supply, driving anything that might have some capacitive on the input. If you know the value of the capacitor, you can use that value and set that parameter in our load. The dynamic modes of operation, these are typically used for things such as transient response, battery resistance and impedance, and they're normally operated in constant current mode. Chroma's added the constant resistance dynamic feature as well, and it gives you the ability to set 2 different times, 2 different amplitudes of current, and the rise and fall times as well. We can do time settings as low as 20 microseconds all the way up to seconds, frequencies up to 25 kilohertz, and you can also vary the duty cycle. So the dynamic loading for a transient response test, normally AC-DC or DC to DC converter, looks at a sudden change in current, and you review the voltage change, peak positive and peak negative, and the time to determine how well it can respond to these sudden changes. There's a number of several excellent white papers out there on the market that I refer to. Texas Instrument has a great one on AN App Note 1733, and Linear Technology has an AN104F that goes into a lot of detail about transient response testing and also the analysis of it. So if you have any questions regarding that, we'd be happy to help you with that as well. So again, settings for range can be set, 2 load amplitudes for L1 and L2, slew rates for rise and fall, they can be different slew rates, frequency and duty cycle settings. And then when we run the test manually on the front of the unit, you'll see the display includes the settings. It also includes the average voltage and current, as well as the peak positive and peak negative current and wattage. It'll tell you what range you're in as far as constant current dynamic, high range. It'll also tell you what your V-on setting is. You can set a V-on for the unit, the load to be applied at a different level. Up here in this corner is our soft panel. This is a general user interface that we've used, and with the general user interface, it can be used with any of our interfaces to control the unit. It's written in LabVIEW. It's a totally standalone executable LabVIEW program. You're going to be seeing a lot of screenshots of it during my presentation, but this is the one that you would use for setting up your basic dynamic test. Now, with that said, you can also use a variety of different ways to program our loads. You can use SCPI, the standard commands for programming instruments. You can use LabVIEWs, LabVIEW VIs. We also have lab window drivers. So we can actually program through these different ways, and we can support you there as well with any questions you might have. Digitizing measurement is something that we implemented along with this. With our software and our soft panel, our general user interface, we can capture voltage and current down to 2 microsecond intervals and with up to 4,096 data points. That's actually going up higher in our 63200A family. And you can see, comparing it to an actual screenshot of a scope, you can see how well it replicates that information. So when you're doing a transient response test, sometimes peak plus, peak minus doesn't tell you the whole story. So you need to review and look at it from an oscilloscope. With our software, you really don't need the oscilloscope. You can display and view the information built into our software. So dynamic application, another application for that, of course, transient response would be the big one for most DC to DC converters. But you can also do battery DC impedance measurements very accurately using our digital measurement capability. A typical good device, you can see a normal delta voltage, delta current may not capture the sharp peak that you would see drop out, which would indicate an impedance or a resistance of that particular battery or cell. By adding the ability to view that dynamically with our soft panel, you'll be able to capture the differences and do comparisons. It's a great troubleshooting tool to see the aging of a battery, or also to compare a batch of batteries. Dynamic sweep function is something that we also have added. This gives you the ability to do your dynamic loading and also sweep it over a range of frequencies. More and more customers are asking that we do a dynamic sweep. This particular customer spec sweeps the repetition rate from 50 hertz all the way up to 10 kilohertz at different load levels for each of the different output voltages. And so by doing that, you're actually looking not only at one point where people would normally look, but as you increase the frequency, narrowing down the width of the pulses, and the time between pulses is narrower as well. Then you start to see a change in the response time of your power supplies to a point where it may not be able to handle some of the higher frequency load requirements like this one requires. So dynamic sweeping, again, we have the ability to capture that data with our soft panels. Here's a nice view of it compared to a screenshot from an oscilloscope. And again, you can capture this data and view the data very easily. Sinewave Dynamic is another way. A lot of people use not the more stringent high slew rate narrow pulse type of transient response testing. In this case, you can use an actual sine wave riding on top of a DC current to create this sine wave dynamic test that you can perform, capturing the voltage and the current, and it will display the voltage plus and minus peak during the test as well. So Sinewave Dynamic, it gives you all this information also at the front panel. You can use this manually. Most of the tests I've defined here can be set up and used manually from the front of the unit. Programmable sequences is something that we've had for a long time on all of our loads. This gives you the ability to write individual step functions within various currents. And you can go all the way down as low as 100 microsecond in sequence size. You can set the amplitudes at different levels. You can even use different modes of operation. So for instance, if you wanted your unit to start up in a constant resistance mode and then switch to a constant current mode, and then at some point switch to constant power, you can do that, and you can do it with up to 100 sequences, with each sequence having a different load amplitude setting and also different time setting. It can also change the rise and fall slew rates or rise and fall times independently. And this gives you a little indication here. This is our soft panel again. And then next to it there, you'll see a live screenshot. You'll also see the actual display on the front of the unit when running the test. User-defined waveforms is something that we've found a big interest in by many of our customers, and this is a tool that allows them to actually capture the data from either oscilloscope or a high-speed data acquisition unit, and capture the raw data, which would be either a CSV file, where you could load the raw data into an Excel file. And from there, we can go up to 150,000 data points, up to 10 waveforms, up to a total of 1.5 million data points. With our incremental or with the interval time as low as 10 microseconds, with up to 25 kilohertz in frequency. And with this, you will be able to replicate the exact current that your unit is driving with the load that it's driving. So whether it's whether you're driving it from a battery to a DC motor, or a battery to a some type of electronic device internal to an electric vehicle, a battery charger driving an actual battery as the load, or even high-speed type transients that you would see when driving any other type of device, whether it's a medical device, a server, computer, even small handheld devices. Because we have such a wide range of power ratings on our loads, from 100 watts all the way up to 24 kilowatts, we can cover a wide range of products as well. So when we do the user-defined waveforms, we can store them. This is kind of a one quick example I put together. This is an Excel spreadsheet. I've got 4 waveforms loaded into it. Each column has the actual current values that were captured from the waveform, each data point. And then these can be plotted in Excel, but you can also just download these directly into our load and run them. Once they're downloaded, you don't really need the computer to run it. You can also activate these manually from the front of the unit. External waveform control. This is gives you the ability to use an analog input, a 0 to 10 volt input, which will give you 0 to full scale on the load output current settings. And there's various ways to use it: constant current, constant resistance, constant voltage mode. The external waveform control is a great tool used with hardware in a loop, power hardware in a loop, or any unusual types of load configurations that you might want to use on your unit. You can drive it from an arbitrary waveform generator or from a function generator or any device that will give you a 0 to 10 volt output and give you the range required to drive these different loads, different set load settings. So external waveform control goes through, we have a connector on the back of the unit, very easy to set up. Again, you can use arbitrary waveform generators to do that. Built into our units, there's also overcurrent and overpower protection testing. Most devices such as DC to DC converters, AC DC power supplies typically require that they have some type of overcurrent protection or overpower protection. With this, we can ramp up our current from a start current to an end current. We can set different dwell times or the number of steps, and we can set a high and low spec level to run the test. During the test, it will ramp up while monitoring the voltage. When it sees the voltage fold back, it will capture the last highest current measured, and that will give you your maximum current point. It'll also give you your power level as well, tell you what your maximum power was at that point. So you can use it for both overcurrent and overpower testing. Battery discharge is another test that's built into our units. For those of you that are testing battery discharge, the unit has various settings for modes of operation, the load amplitude, the timeout setting, and the in voltage or cutoff voltage. Also gives you slew rate settings for amps, and it will measure ampere hour and watt hour capacity while it's running the test. It'll record that data to a report, and you'll be able to do that with and save the settings in the soft panel for a variety of different products that you might be testing. It's great from everything from a small cell phone battery all the way up to battery testing for electric vehicles and energy storage. So the settings for battery discharge are pretty straightforward. There is a mode setting, a current setting, slew rate settings, end voltage, a timeout, and range settings. Easy to set up, and you can also do that manually from the front of the unit. Combined operating modes, these are something that's unique that we've put into our new products. And this gives you the ability to automatically control multiple dual type mode settings. For instance, if you're turning on a power supply into a load, you may, like we mentioned, want to start up in constant resistance, but you may want to have a better regulation of the current once it reaches its maximum voltage. At that point, the unit would switch from constant resistance to constant current mode. This is an automatic mode of setting. You don't have to program each one timing or do one and then switch to the other. It will be done automatically, switching constant current resistance to constant current. The constant voltage, constant resistance, this is typically used to like for a battery charger type test, where you would start off in constant voltage mode, bring it up to a particular voltage and current level, and then switch to constant resistance mode for the remainder of the test to demonstrate or simulate an actual battery being charged. And then there's a turn on level. Constant voltage will allow you to not turn on until a voltage is reached. At that point, then it will switch to constant current. So these are great tools that have been added to our products, and we're finding a lot of applications where you can use these. Another feature that we've added to our units is what we refer to as maximum power point tracking, MPPT. And what this does is you can hook a solar array or a solar panel directly to our load, and our load will do an automatic sweep to find the maximum power point. You can do it based on a solar panel or solar array under natural sunlight, and you can use it to track the power level over time, or you can do it under an artificial light, do a short-term test where you can go in and verify that your panel meets the requirements or the specifications for that solar panel. Again, it's called MPPT. It's built into the unit. There really are no settings. You run the test. It will do an automatic sweep, and during that sweep, it will give you your maximum power point. And to our software for this, it'll also give you a distributed curve like you see here, which is referred to as the VI curve for the solar panel. It'll also give you an indication of short circuit current, open circuit voltage. Those of you familiar with solar panels, these are the key points within any IV curve for a solar array, solar panel. Paralleling the units, again, the paralleling of these units up to 10 units, 240 kilowatts. We can do master slave or sync, where even with these paralleled units at the higher power, you can still do the full range of tests that with the slew rate settings the same, and be able to handle doing various types of transients, whether they're dynamic or whether they're various settings within different modes of operation. These units will be able to handle it perfectly. Now, that's everything I have to cover presently. We've gone into 43 minutes. We were hoping to keep it down to 30. But I'd like to open it up to some questions that you might have. Again, you can also reach us online. Our email address, I'll post it. I thought I had it posted here, but let me post that for you. So you can reach us on our website, which is chromausa.com, but you can also reach us through our apps engineering. And you can also reach us, you can reach my email address is Larry S. at chromausa.com. And I may not be able to answer all your questions, but I can definitely help direct those questions to the right people.